Well, it's been called one of the greatest breakthroughs of biological science in our generation, and it just got better. Google's DeepMind is unveiling AlphaFold 3. It's a major upgrade to a previous platform that helped scientists understand the proteins that make up our bodies, but also the ones that cause diseases. Joining me with more is Dan Riskin, CTV's science and technology specialist. Dan, I read through the data time and time again. I still don't quite understand. So what is AlphaFold?
Well, so basically, it's to understand how proteins interact. A protein fundamentally is a string with a whole bunch of beads on it. Those beads are amino acids. And so we know very well what the order of beads is, but what gives a protein its abilities is when those beads are released into a fluid and they bunch up into a shape. And that shape is what gives it all its properties. And when a weird-shaped protein interacts with another weird-shaped protein, things happen. And these beads, there could be hundreds and hundreds or even thousands of beads on a protein. And so, like, yeah, look at that picture. Like, it's ridiculous. How on earth are you supposed to calculate what that is? So for decades, scientists have been using X-ray crystallography to measure the shape of proteins. And they had done a great job. They'd gone through like 100,000 of them. And then Google says, oh, we can do this on a computer. And all of a sudden, just in 2020, they said, here are all the proteins. And they gave the shapes for all of them calculated with artificial intelligence. And this is one of the real examples of the promise of artificial intelligence. And now all of a sudden, instead of having to do the heavy lifting of figuring out what each individual protein does, we just have the whole database available. So
you mentioned that sped up timeline, Dan. Just to give our viewers context, an earlier version of AlphaFold that was released in 2020 solved the puzzle that scientists have been working on for 50 years. So this was over a long period, 5 decades, that protein folding problem. So AlphaFold 3, pardon me, how does it build on the original platform?
Right. So it was already like amazing. And we already like had the future brought to us in 2020. And scientists have been just running like crazy with this tool and doing great things. But now AlphaFold 3 has just been announced. And what AlphaFold 3 does is it does the same thing with proteins, but it also can do DNA. It can also do RNA. It can also do antibodies. It can also do ions of metals, all these other things that interact with proteins in the human body that have important effects, like drugs, like vaccines. And so being able to calculate all these things, it's not just about being able to understand what's already going on in your body. It's about being able to take this computer and say, hey, I need a drug that's going to stop Alzheimer's. Here's the protein. What do I do? And then with AlphaFold 3, you could say, well, here's your protein. Here's its shape. Wouldn't it be interesting if you had an amino acid come in here? What if we had an antibody over here? You can start coming up with new ideas that are inspired by the actual shapes of the proteins and start tackling problems in whole new ways. So this is, I mean, to say game changer just is an underservice to the term game changer. It is huge what AlphaFold 3 is going to be able to do for medicine.
Well, it seems like the obvious next step would then be to have complete personalization for any sort of medical treatment, because you could say, well, hey, if you have Alzheimer's, but you also have this, let's customize something that fights your specific diagnosis.
Exactly. So this tool is freely available to scientists. It's not open source, and there's a little bit of rumbling about that. People would like it to be open source. The original one from 2020 was open source, so there's going to be grumbling there. But any scientist can use this, which means if you have a patient and you know their genetic sequence and they have maybe a little bit different DNA from the last bunch of patients you treated, you might be able to anticipate what that's going to mean for drug delivery. You might be able to make a custom drug that works exactly for their DNA sequence. And we're really moving into this era of personalized medicine. And AlphaFold 3 is definitely going to be one of the basic tools that makes that possible.
Well, and what's really cool, too, here for our viewers, like we talked a lot about medicine, Dan, but besides medicine, this is available across all sorts of science. So what could this platform be used for?
Well, I'm sure it's going to move bat science forward quite a ways, which I'm very excited about because that's my wheelhouse. But really anything with proteins, right? So that's all of biology. It's a lot of chemistry. It's a lot of human medicine. But really, this is just a giant tool that really moves things forward. I mean, proteins are fundamentally, they're really simple. Like I said, it's a bunch of beads on a string, but they are so powerful and they do so many things that make the world work. And now to have this tool that can show us how proteins not only interact with each other, but interact with other things in the world is just going to help us understand the world a lot better. So you're right. It's not just about human medicine, but it's huge in human medicine, but it's going to be even bigger than that.
Dan, it's great to have you on the show. Thank you.
Thank you.
Hey, thanks for watching. If you liked this, be sure to subscribe here, or you can check out more Your Morning videos right here.